Floating in the Pacific Ocean is the Great Pacific Garbage Patch, an enormous swirling soup of plastic, nearly the size of Alaska. It's not a solid island, but a thick cloudy mix of about 1.8 trillion pieces of plastic weighing 80,000 tons, and it's just one of 5 massive garbage patches in our oceans, formed by powerful currents called gyres. Every year, up to 14 million tons of new plastic waste enter the oceans, about 2 garbage trucks worth every minute. Plastic is everywhere in our lives, but most of it is used once and thrown away, often ending up in rivers and, eventually, the sea. The result? Our oceans now contain up to 51 trillion microplastic particles from the surface to the deepest trenches. These tiny fragments are the weathered remains of larger items, now polluting every corner of the ocean. We've created a global plastic soup, a crisis that demands urgent action. But there is hope. Science and engineering are giving us new tools to fight back. Understanding the scale of the problem is the first step. Now, let's see how this plastic soup harms everything it touches. When plastic enters the ocean, it becomes deadly for marine life. Sea turtles mistake bags for jellyfish, seabirds eat bottle caps, and both can die from blocked digestive systems. Over 800 marine species are affected, either by eating plastic or getting tangled in it. Microplastics are even more insidious. Tiny particles eaten by plankton and small fish, then passed up the food chain. This process, called biomagnification, means top predators, and humans, end up with high levels of plastic-related toxins. Microplastics have been found in seafood worldwide, and the health effects are still being studied. Plastic pollution also smothers coral reefs, ruins beaches, and damages local economies. It even disrupts the ocean's role in regulating our climate. The plastic problem is environmental, economic, and personal. Its consequences ripple through the entire planet. The scale of ocean plastic is daunting, but innovation is rising to meet it. The ocean cleanup, led by Boy and Slat, is using massive floating barriers, like System 03, a 7,200-foot U-shaped collector, to gather plastic from the Great Pacific Garbage Patch. These systems use ocean currents to passively collect debris, allowing marine life to swim safely beneath. Once full, support vessels haul the plastic to shore for recycling. The goal: 10 systems could clean the entire patch by 2040. But stopping new plastic is just as important. The Ocean Cleanup's interceptor is a solar-powered barge that catches trash in rivers before it reaches the sea. Interceptors use floating barriers and conveyor belts to collect waste, alerting teams when full. Over 20 interceptors are already deployed worldwide, stopping thousands of tons of plastic each year. Partnerships with influencers like Mr. Beast have brought global attention and funding. Technology is making a real difference, but collection is only half the battle. So, why not just recycle all this plastic? The reality is, most recycling methods fall short. Mechanical recycling, shredding and melting plastic, only works with clean single-type plastics. Ocean and river plastics are mixed, dirty, and degraded, making them nearly impossible to recycle this way. Each recycling cycle weakens the plastic, so new or virgin plastic must be added. Only about 10% of all plastic ever made has been recycled. The rest is burned, buried, or polluting nature. Many products are made from complex, multi-layered plastics that can't be separated mechanically. Chemical recycling exists, but it uses extreme heat and lots of energy, creating a big carbon footprint. Even then, plastics must be carefully sorted, and many contaminants still cause problems. Our current recycling system simply can't handle the scale or complexity of the plastic crisis. We need a new approach, one that can tackle mixed contaminated waste. The answer lies in better science and smarter technology. Let's look at a breakthrough that could change everything. Enter Aduro's hydrochemolytic technology. Aduro Clean Technologies is pioneering hydrochemolytic technology, or HCT, a smarter way to recycle plastic. Instead of brute force heat, HCT uses water, special chemicals, and lower temperatures to break plastics into valuable building blocks. It operates at $350, 420 degrees C, far less than traditional methods, reducing energy use and carbon emissions. HCT is water-tolerant, so it can process wet, dirty plastics straight from rivers or oceans. It even handles tricky plastics like PET, PVC, and cross-linked polyethylene. materials that usually end up in landfills. This flexibility means HCT can tackle the messy, mixed waste that mechanical recycling can't. Aduro is building a pilot plant in Ontario, set to process 10 kilograms of plastic per hour by late 2025. The modular design means these units could be deployed anywhere, even next to river interceptors in developing countries. Imagine local recycling, right where the waste is collected. HCT could turn plastic pollution into a valuable resource, closing the loop for a circular economy. It's a game-changing idea, and it's becoming reality, but technology alone isn't enough. The fight against plastic pollution is a global challenge that demands innovation, teamwork, and action. We must reduce single-use plastics, improve waste management, and remove existing ocean trash. But without effective recycling, we're just shifting the problem from sea to land. Breakthroughs like Aduro's HCT let us see plastic waste as a resource, not just garbage. By transforming mixed contaminated plastics into new materials, we can build a true circular economy. This will take engineers, chemists, governments, companies, and all of us. We need to rethink how we use materials and what happens when we're done with them. The challenge is huge, but not impossible. For every grim statistic, there's a story of innovation and hope. By combining ambitious cleanup with revolutionary recycling, we can chart a new course for our oceans. The future depends on our willingness to act and embrace new ideas. Let's get to work.